Hello, everyone, and welcome to today's live international webinar. There is a famous quote of Arthur C. Clarke, and the quote goes like this: people can live longer without food rather than information. Without information, you would go crazy, isn't it? Yes, we need information on whatever we are facing in and out from every possible way. And today's event will provide you with lots of information in order to cope up with two different scenarios. It is an honor itself to greet you all to this event. It is my privilege to welcome our chief guests, eminent speakers, delegates, and participants on today's webinar. Rajendranath College of Polytechnic is going to host this live international webinar, which is based on two different subjects today. First of all, it's on nanobio technology-enabled biomedical sensor devices for point-of-care disease diagnosis. And the second one is the effectiveness of protected areas in biodiversity conservation in Tunisia. We are delighted and also honored to be able to conduct this event and to make the acquaintance of all you here at RCP. Rajendranath College of Polytechnic is a premier technical educational institute of West Bengal, and it was established by Sri Jayanto Kumar Chakraborty, the founder president of Rajendranath Education and Welfare Trust. RCP was established with the endeavor of providing quality education on technological aspects. We are providing diploma engineering courses in the field of civil, mechanical, electrical, and also in computer science and technology. RCP persistently seeks and adopts inventive methods to improve the quality of higher education on a consistent basis. This institution has been functioning since 2012, and it is approved by All India Council of Technical Education under the Ministry of MHRD, and it is affiliated by West Bengal State Council of Technical and Vocational Education and Skill Development. Well, let me first acknowledge the presence of some of our eminent guests today. Our respected Director Technical of Rajendranath College of Polytechnic, patron of this international webinar, Sri Kajol Das, our beloved principal, the convener of today's event, Professor Tanmoy Sinha, Principal of RAID, Professor Dr. B.C. Swine, and two very important person, rather special person, speakers of today's event, Dr. Gorachand Dotto from School of Medical Science and Technology, IIT Kharagpur, and Dr. Rania Meshegui from University of Carthage, National Research Institute of Rural Engineering, Water and Forest, Tunisia. First of all, we will have our traditional auspicious lamp lighting ceremony. We are all familiar with beginnings, right? They can be small steps, but its impact can be experienced in giant leaps. So, I humbly request our Honorable Principal, Professor Tonmoy Sinha, Principal of RAID, Dr. B.C. Swine, HOD of Basic Science and Humanities, Dr. Somnath Ghatok, HOD of Computer Science and Technology Department, Shri Vikas Mondol, to kindly make a new beginning through illuminating the traditional lighting of lamps. Please, sir. It is a symbolic act of the light that shines within all our hearts. Let us pray for our blessings with all humanity. So, let's start today's program now. Firstly, I consider it a great honor to welcome our patron, Director Technical of Rajendranath College of Polytechnic, Sri Kajol Dash, to give your valedictory speech. Sir, the screen is all yours now. Please.
Thank you very much, and good morning to all of you who are present in today's webinar organized by RCP, and my congratulations to principal for organizing such a great event today. It all brings the knowledge, it all brings the wisdom, it all brings the collaboration. It is a collaborative event. My congratulations to all. Today's the main topic on nanobiotechnology enabled biomedical sensors, devices, diagnostics are apt in the today's world. We all are experiencing that we are suffering a lot. The mankind is in danger and we are suffering a lot. So we need to go more and more further to reach and to get all the sensors. So we need to explore the science, the medicines, the sensors. There is no end to it. My special thanks, what I should say, that Rajendranath Group of Education Durgapur is always putting all efforts to expose the latest information useful not only for the students but also for the benefit of the whole society. It is a great endeavor by the Rajendranath Group of Education and its team. Likewise, it is a call of the day to know the best use of technology and its application in different fields. Technology is a vast, it is an ocean, and different field the technology can assist. You know, the medical science has been continuously exploring more and more avenues to know the unknowns and bring the foolproof preventive mechanism. I stress upon the preventive mechanism, why I will tell you later. Over the years, the technology has come in a big way to assist medical science also for treating symptoms to cure. Now, when we call it preventive, it always means foreseeing the future where the need is defined and it is aligned with the requirement. Then only we can get our required uh, goal, or we can reach at our goal. As it is known, the necessity is the mother of invention. Likewise, many sensors, gadgets, tools are invented over the years for resource of mankind, for saving mankind, and for resource of medical science. Dr. APJ Abdul Kalam rightly said that to understand very large thing, we must understand very small things. As everybody, all of us know that nano is a Greek word, is dwarf. It indicates billionth of a thing. The example of hydrogen atom is zero point 0.1 nanometer. Likewise, width of DNA molecule is 2.5 nanometer. Nanotechnology is simply rearranging and processing the atoms and molecules in its very miniature scale. Now, the sensors and diagnostics, ultimately it comes to the use of mankind. Those are the things which are needed for everyone. Those sensors, I can say, let us say plasmonic nanobiosensors, these are helping diagnostic for the disease at the early stage. Early detection of tuberculosis is one of that. DNA impedance biosensors for the early detection of cancers are being used. There are many producers, many products available in India also, though in India it is in a research stage, but still Indian many, at least 20 to 25 companies, mostly in Kanpur, Mumbai, Andhra Pradesh, Karnataka, Jamshedpur, these technological institutes are there. They are working day and day in day out for finding new and new things. Biotechnology deals with metabolic and other physiological processes of biological subjects, including microorganisms. So, nanobiotechnology has developed to integrate the biotechnology with nanotechnology together. It is in collaboration to reach the goal at the very micro level, and from that micro level we are able to know what is to be done, how we can save ourselves, and how we can bring the product with the help of technology. Nanoelectronics, if I say on the technological front, nanoelectronics has come in a big way. The electronics we all know, that conventional electronics we all know, but exploiting the traditional strength of semiconductor industry, miniaturization and integration has brought this nanoelectronics in a further detailed and very micro level, so that we can go deep into the subject. Added advantage of conventional electronics, we all know conventional electronics has already brought the very innovative things, pacemaker, brain stimulators, like that. But example of nano technology which can bring, say, brain, they are working on brain research, they can repair our brain, and we are working on that. Our entire human society is working on that. Let us say on the product, a product developer are like Adnano Technologies Karnataka, Advanced Nanotechnology Mumbai, as I already told. There is a consultancy and services also available in India. Avanza Technology and Services in Kanpur, and they are very, so far as I know, they can bring more and more knowledge, hub, knowledge, give you more and more knowledge in this subject. BKM, Kanpur, like many others. So, what is the ultimately, uh, it is an eye opener for us, for the technical schools, for the students who are who can explore a new world of technology. There is a vast scope for entering into this technological hub. Finally, more and more we go in the micro and nano deep into the subject of any subject. The technology is ready to give you the shape you want, what you want, that is most essential. So what you want, and you go deep into it, and you will find out with the help of the technology is available. And it is evident that there is a big field where technology has a big role to play and will create big knowledge hub, as I told. Now there are lot many academicians in our India, and today as we proceed further in our seminar or webinar, we will come to know many more things from the eminent speakers, that how this field has grown and how more we have to go. We have to go. There is no end to it. We have experienced already that we thought the mankind has explored everything, but the entire world has experienced already that we are the victim of nature. We cannot surpass nature at any point of time. We can take the assistance of technology, but we cannot dictate the nature. So we have to do whatever we want. We have to take the help of nature along with that. The industry academia interface or collaboration are most essentials at the moment. The Rajendranath group of education is doing that with the eminent speakers, bringing them to this field, to this lecture session. They will just light up the mind, they will just provoke the mind of the students, and the students who are interested, they can enter and they can go further beyond into the subject, and they can bring many more laurel. Academicians jointly with technical experts are developing everything. Nowadays, everything is possible, my dear. If we want, we can do miracles. If we want, we can bring many innovative things in future. And the second subject is a very interesting, biodiversification. We all know the mankind can be protected only if we, already I have said, if we only protect our environment, if we only protect our nature. In last 500 years, the deforestation, I will give you a brief example. The deforestation which has taken in last 5 years has surpassed the last 500 years record. The deforestations are coming in a very aggressive manner without understanding the subject. We the academicians, we the sensible citizens of India, we need to think how we can protect our environment, how we can protect our nature, and how we can bring the entire ecological balance. Without ecological balance, we cannot survive. We cannot survive by just eliminating one part of the nature. If we kill the mosquitoes at any point of time, if we kill the frog at anywhere, at any place, if we kill the snakes at any place, it will entirely damage the ecological chain, and it will bring a massacre to the mankind. And you all know what are the reasons, because mosquitoes, snakes, every frogs, everything is required in this nature. We cannot live without them. So my dear friends, I expect that today's session will be very useful, and will get lot many knowledge and ideas from the academicians, from the eminent speakers. I am also eager to know what is going around the world, and how we the technical schools can intervene, and we can know, we can bring more and more good things, more and more innovative things for the society. Thank you very much. Thank you.
Thank you very much, sir, for your wonderful speech. Now, I would like to request our convener, our respected principal of Rajendranath College of Polytechnic, Professor Tanmoy Sinha, to convey your message.
Good afternoon. It is a great honor for me to introduce and welcome our honorable speaker, Professor Dr. Gorachand Dotto Sir from IIT Kharagpur and Professor Dr. Rania Mekhagui from Tunisia. Honorable Chairman Sir, CEO Sir, Director Sir, and distinguished guests, ladies and gentlemen. At first, our first speaker, Dr. Professor Gorachand, is from School of Medical Science and Technology, IIT Kharagpur. His topic of the webinar is on nanobiotechnology enabled biomedical sensor device for of care disease diagnosis. Actually, he is from Kharagpur. He has received many awards such as BK 20 Awards South Korea Chief Minister Talent Award, MCM IIT Kharagpur Award, and Telegraph Award. His research area is on lab on PCB, biosensor of point to site application, fuel cells for self powered devices, LAM on the chip device for diagnosis of biomems for low cost integrated technology. Today, we are about 1,000 participants from industry experts and professionals joining this webinar, and the participants came together here to discuss on the topic nanotechnology enabled biomedical sensor device for point of care disease diagnosis. Today, we are privileged to have an opportunity to listen from Dr. Gorachand Sir. On behalf of all here we gathered, I welcome you, sir, for the literary afternoon of the International Webinar. Thank you, sir.
Thank you, sir. Well, let's focus on today's first topic of the event, which is nanobiotechnology enabled biomedical sensor devices for point of care disease diagnosis. Explicitly, a nanometer is small, very small. To be precise, a typical sheet of paper is 1 lakh nanometers thick. Nearly 50 years ago, Richard Feynman gave an eminent speech in which the idea of nanotechnology was first envisaged. He wished if he could arrange the atoms one by one the way he wanted them. And it took 30 long years for microscopes to be developed and permitted the revolutionary vision to be comprehended. So, to provide us with ample of information regarding this technology, I am pleased to welcome the first speaker of today's event, Dr. Gorachand Dotto from School of Medical Science and Technology, IIT Kharagpur. We are very excited to hear from Gorachand sir on his research work, which is very interesting and important in modern immunosensors and electrochemistry. Dr. Gorachand sir is going to demystify his personality, and he will give us lots of practical ideas on nanobiotechnology-enabled biomedical sensor devices for point-of-care disease diagnosis. Please join me in welcoming Dr. Gorachand Jotto. Sir, the screen is all yours.
Thank you very much. Very good afternoon, and many thanks for inviting me in such a good international webinar. So let's start my presentations. Can you see my slides? Hello, can you see my slides? Hello, can you see my slides? Can you confirm me? Hello, can you see now? Can you see my slides? Okay, can I start now? Okay, okay. Okay, my sound is audible, right? Okay. Okay, so my topic is the nanobiotechnology enabled biosensor devices for point of care disease diagnosis. So it's very interesting topic in this current scenario, because in this COVID-19 situations, so we should know the basic mechanism or basic how we can develop a simple diagnostic device that can be useful for near the patient. Basically, we are missing this one currently, right? So this is our main focus area now at IIT Kharagpur, how to develop a very simple device like in the market right now available like glucometer or pregnancy test meter. You know this one, right? It's very, very simple device and it is easily accessible, and common people also can use this one. No need any trained person. So we can easily use this one. So my main goal to develop such kind of things device. So basically, I will start some introductions, and then I will tell you what's the nanobiosensors for digital diagnosis. And finally, and this is the very, very important thing, is the commercializations. So basically, many industries, many companies, they're looking for this topic, right? Commercializations. Without this, we can't do anything for mankind. So this is very important. Then what's the future prospects of my research and my group are doing right now in IIT Kharagpur? That also I let you know. Yeah, this is the very best things people should know or already know, that is the health is wealth. So wealth is, so it means health is the biggest wealth. So without a good health, we can't enjoy our life, right? It is a, so that's why we should, I mean, regularly we should diagnose our health conditions. We should diagnose all the disease. So we can't avoid the disease right now, right? So if we can detect at the early stage, if we can stop them, then basically, yeah, we can prevent the disease. We can make ourselves healthy. So this is the main motive of this presentation right now. But what's the current scenario in the whole world right now? We are in a big trend now. See, HIV, malaria, tuberculosis, all over the world, almost more than 50% world suffering from different kind of the chronic disease like diabetes, obesity, and right now, the cardiovascular disease all over the world is the number one cause of the death. And in India also, in all the states, people are suffering different kind of cardiovascular disease. Many people are dying every day, every minute. So, and the current time, the SARS-CoV-2 came, the COVID-19 is a big threat now. So basically, the many diseases there, but what's the possible solutions in our hand? Do we have this? But for the diagnosis, see what's the scenario right now? We have to go to the hospitals, we have to give our samples, they will send to the laboratory, and we will depend on the very strong, powerful instruments, very bulky and very expensive. Not only this, we have to wait for a long time also for our result. Sometimes we can't detect the disease also at the early stage because people are not going regularly to the hospital to diagnose their disease. So think about the rural area and very poor people. Sometimes they are fearing to go to the hospitals and diagnose their disease. So that's why if we can't detect the disease at the early stage, sometimes we can't save their life. So in the current diagnosis situations, generally we are depend on the very powerful instruments in the laboratory based, but that is very much laborious. And generally we need the time. That is another very drawback for this time consuming protocols we are following. And very trained personnel they are doing. Means it is not possible to do near the patient, or some common people can't handle this one. We need very trained personnel. And also can't miniaturize them easily. See, if we can miniaturize easily, then only you can use in our home, like the glucometer. So this is another drawback. And also another thing we have to think about the on-site diagnosis, not the laboratory base. So this is the main drawbacks right now. And biosensors, this is the one advanced topic that we are working on. We are focusing right now is the main solutions. We can solve this kind of problem by using this advanced technique. So let's introduce this one. What's the biosensor? Biosensor is the analytical device which is included one or more biological recognition elements. Biological recognition elements means like antibodies, peptide, aptamer, enzyme, DNA, RNA, very nano size, different kind of biomolecules we can use on the surface of biosensor surface. And we can detect specific disease marker at the early stage. So let's show you some schematic diagram. See, this is the sample, like blood or some saliva or urine samples that contain many kind of the interfering species, including the disease. Now, in a transducer, that is the surface of the biosensors, that will contain a specific biorecognition element. Just I told you, the antibodies, peptide, this kind of things, we can immobilize on the sensor surface. Now, if your sample contains disease marker, so it will capture on the sensor surface. And one very important thing is this is very specific. See, if your blood sample contain like malaria and dengue, both disease, but if you want to detect only dengue, not the malaria, so our sensor surface will immobilize only dengue related capture probe, like antibody, something like this. So they will capture only specific marker like dengue. And we can apply potential or something that we are going to use, and we'll get the output signal in the form of current or charge or color, something like this. And we can tell them how much disease biomarker present in the real samples. See, there are many techniques right now available for the biosensors, like electrochemical biosensors, colorimetric, mass biosensor, thermometry. Electrochemical means we are applying some electrochemical potentials. Colorimetric, some change of color. Mass means change of mass change, or thermometric change of temperature. But right now, actually, we are focusing very strongly on the electrochemical biosensor, this area. So why? Because this electrochemical sensor is very simple technique. And at the same time, this is very much sensitive. So why? So we can detect the disease at the very early stage. So the device should be very, very sensitive. Otherwise, if we can't detect the disease early stage, sometimes it's impossible to save the patient life. Think about the cancer stage. If we detect the cancer at the later stage, so it is very impossible to save their life, right? So that's why sensitivity of the sensor device is very, very important. Another easy to miniaturize. So if we develop a very bulky instrument, we can do it inside the lab, not near the patient, not in the home, not near the. So that's why the miniaturization is very, very important factor, and affordability. So why? So in the developing countries, we have to think about the mankind. Right? So if it's not affordable, it is not cost effective, it's not cheap, then common people cannot use. So that's why affordability is our another focus. So right now, actually, smartphone-based platform we are developing, because right now many people are using the smartphone. So although many rural area and although developing countries they can't use the smartphone, so for that we are developing the another chip. But who already using the smart? Because right now, because of the vast technological change, many people all over the world are using the smartphone. So if we can develop any chip that we can easily insert where we are plugging our smartphone. See, where if you can easily insert the chip, we can get the data. And for this chip, no need any local reagent, no need any special equipment, no need any trained personnel. Only what you will do, you will drop the sample, you will run a app in your smartphone, and you will see the data. That's all. And because of the IoT, Internet of Things, we can easily store this data in the cloud or in the database, and you can send the information to the doctors, and they can give you suggestion immediately, or any emergency situation, they can take care of it. So this is the main driving force of the biosensors. This is the main driving force of our research right now we are doing. That is, bring the rapid test method, convenient and immediate proximity to the patient. So let's see the biosensors. Let's give you some basic examples. So it is the beginning of the life, like the pregnancy test meter and glucometer. This is the two basic examples right now available in the market and commonly available, and people can easily use. Because they're very, very simple. Just drop the sample, you can see the data. And also we can print the biosensor on our skin, and this is called the printed biosensors. We can easily print, and we can see the result, and we can transfer the data to the smartphone, and we can that will inform you if the disease or not. Right now in the biosensor area is very, very hot topic, and worldwide is a very big business market, and publication wise is going rapidly increasing. And also, if you think about the different kind of the technique of biosensor, we can see this, the black bar is the electrochemical biosensor, is the main hot topic, our focusing area. And what we are doing at IIT Kharagpur right now, we are doing developing different kind of the advanced sensors using electrochemistry, using nanobiochemistry, nanotechnology, and we are functionalizing the surface, different kind of the nanomaterials, nanobiomaterials, and we are detecting the different disease. And also we are designing the device, and we are patterning, we are using a micro patterning technique and miniaturizing them and use them for mankind. So we are using different kind of advanced technique for characterization of the device. So basically we are using very much interdisciplinary. We are actively and collaborating with different industry, with different companies, with many academics internationally, and we are designing different concept, and we try to commercialize our research for the mankind. So this is our main research, different kind of the nano-based biosensor, ELISA, biomems, microfluidics. So this is different kind of topic I will describe today. So actually, this is the kind of summary I will tell you today. So how we can develop. So this kind of the you can be very small. This is like a SIM card, very small. You can see a microfluidic chip, very small chip. So we can easily integrate this one with the help of some electronic. We can easily insert this one to a smartphone. We can run the app. We can see the data. Here we will drop the sample. The sample will go through the sensor, and it will show the data, how much disease biomarker there. And here actually one basic and important fundamental things I am using, that is the signal amplifications. So why I am repeatedly saying this one, amplifications, because our main goal detect the disease at the very, very low level, so that we can detect the disease at the early stage, we can save the patient life. At the same time, we are focusing another area, that is like this very small chip. We can drop the sample. So sometime you can see some area or on site diagnosis, maybe there may be problem with the power shortage or there is no power. So we can generate the power also inside the device. So no need the external power source. That is called self-powered biosensor device. No need any external battery. So because see our sample like blood, it contains the glucose. So it will itself help to generate the power. How the glucose contain also energy. That also I will tell you. So let's come to some basic example for malaria detections. Right now I'm focusing the two topics. One is the malaria, and in this situation, especially right now in the West Bengal, also in the rural areas, you can see the malaria, dengue is the right now is the common threat, right? So people are dying also. So if we can detect the disease at the early stage in the dengue also, so we can save the life. We can go for the proper treatment. So this is kind of a basic chemistry or basic funda that I'm going to tell you. How we are developing the sensors. So see, this is the actual sensor surface. It can be a nanoparticle coated glass electrode. It can be a gold electrode. It can be different kind of the like carbon nanomaterial, something like this. We can easily immobilize or capture probe like antibody, aptamer, DNA like this. So here actually for malaria detection, we use the antibody antigen affinity method. See here, this is the IgA, is called this antibody, that is the capture antibody that can specifically detect the malaria antigen. That's called the PFHRP2. So if the sample, your blood sample contain malaria, so it will easily immobilize this biomarker on the surface. And because our blood sample contain lots of interfering species, right? Other marker also, but they will not immobilize. This is the beauty of the biosensors. So only specific marker will be immobilized on the surface. And we will use some chemicals we can drop on with the samples, like some secondary antibody, option nanomaterial, so like platinum. Why we use the platinum? Because here platinum actually helping us generate the higher signal to background ratio. So what is the signal to background? Background, if there is no disease, so we will get a signal, right? If there is a disease, then we will get a different signal. This signal difference is the signal to background ratio. So here is the some data we can see, the like electrochemical data. So this is called the cyclic voltammogram. This is called the chronoamperometry. So in this is the chronocoulometry. So chronoamperometry. So like the different kind of technique we can use. So this is the background and this is the signal. So this signal difference we will get if there is a biomarker concentration difference in the samples. Let's come to some data. So here we detected some saliva sample that contain the malaria. So you can see there is a signal difference with different concentrations. So this is the signal difference, different concentration of the malaria. So we can detect almost 1 picogram per ml, and very, very low level malaria biomarker we can detect. Also, it is very important for the sensor device, the specificity, as I already mentioned, because if the blood sample contain the many other biomarker also, they should not interfere your device. See, so our aim is the PFHRP2. So it should show the signal, and PFL is another marker. It should not show the signal. And this is the control, means zero data. So if the control and other marker, they are similar, it means the device is very much specific, very much selective device for your PFHRP2. Actually, this is the, with increasing the concentration of biomarker, signal slowly decrease. That's why in the case of malaria, we are getting the lower signal. Now come to the ultra sensitivity. Now the another research we have to focus on how we can improve the signal to background ratio. That is called how we can develop ultra sensitive biosensor. We can go very, very low level biomarker we can detect. So actually, this is some basic chemistry we use here, some cyclic chemistry. If some malaria biomarker there, so with the help of some reagent, cyclically, it will generate signal. Because of this kind of cycling, we'll get very, very high signal because of this kind of cycling. So see some data here. So in the blood sample, actually we check, in the blood sample, we can go femtogram per ml. It is very, very low level. And this is the calibration curve. You can see if we increase the malaria concentration, I mean, if the malaria marker increase in your sample, the charge, I mean, output signal also slowly increase. And in the same case, this is also very, very selective biosensors. We can use them for malaria diagnosis. Similar way, this kind of device we can use for dengue also. Now the challenge. So this kind of sensor we develop in the lab, but how we can bring them to the common people, how we can use them in the device, right? This is the challenge. So what we are doing in the lab, that is called like a bedside. Now we have to apply for the bedside application. So that's why the main challenge is the quick detection and on-site detection. But right now the answer is almost no. We don't have so many this kind of the devices or this kind of the important devices right now available in the market. So that's why it is very much interesting to study some protocol or some technique that is useful for point of care testing. Yeah, I developed one important technique, that is the washing free technique. You know what the diagnostic people are doing in the lab? So they are step by step, they are developing their assay. Like they need many step washing. And then finally they will give you result. Maybe sometimes they take a few days also. But if we can avoid this washing, like just drop and detect the data, then that will be very useful for device, for the point of care device. So see here. So this is the actual like antibody coated one sensor device. This is the complete chip is ready to go for detection. Now, so what do common people will do? The common people can handle this one. So they will drop the sample in a tube, and some reagent already will be there. They will mix it and drop on the sensor surface. So when they will drop, if the target means the biomarker or disease marker that we are looking for, so that will immobilize on the sensor surface. And some, as I told you, some chemicals already there in the tube. So they, on some bio reagent also there, they will bind on the surface. And when you start the app, or then we will apply some potential, some electrical current, so we will get some output. Now, if your sensor surface contain like biomarker, so when you will get the signal, it will show the first signal generation, and will go the higher signal. And on the same side, this is the another side. If the sensor not contain any kind of the disease, it will show the slow signal. I mean slow reactions. It will give the lower signals. So let's show you some data right now. So this is the basic principle. Now show you data, then you can understand. We use this principle for the detection of cancer detection, that is prostate specific antigen detections. Just we published this one in the American Chemical Society, Chemical Chemistry. This is the some analytical chemistry journal. We published here for detection of prostate specific antigen. So we detected almost 10 picogram per ml PSA using this principle, and we compare with the standard instrument that's available in the hospitals. And we can see this in this diagram, like our data and hospital supply data is almost matching. It means it is very reliable. Also, we tried this kind of the sensors for detections of the different kind of the cardiac biomarker, different heart disease biomarker detection, like troponin I. So, as I mentioned before also, that our samples, our human body fluid samples contain a lot of interfering, like ascorbic acid. So, ascorbic acid, that is vitamin C, there is very much interfering species for the sensors. Uric acid, acetaminophen, they are very, very interfering species. So we should eliminate this kind of interference species effect in your sensors. Otherwise, your signal data and your background data will be overlapped. You can't differentiate. You can't detect the disease at the early stage. So in this sensor, actually, we showed how to eliminate the interference species, this kind of the interference species that present in the body fluid. So actually, here you can see, actually, this is the potential window cyclic voltammogram. We can see that interference species actually activity showing in this region, But if we apply our application potential in this region, that is almost not showing the effect. So that's why in our device, we applied the potential around 0 or 0.05. Then we can eliminate the interference species effect. And finally, we use them for the detection of cardiac troponin I. And we detected almost 10 picogram per ml. Yeah, so this kind of the sensor is ready to go now for devices. So now come the another challenge, how we can implement them to the sensor chip. So that's why this is the very fancy name, the lab on a chip. So why lab on a chip? All the laboratory experiments what we are doing will bring to the chip, like sample injection, sample mixing, sample separation, reactions, amplifications. All the steps will be inside the chip. Means all the laboratory experiments now will be on the small miniaturized device. That's why it is called lab on a chip. So like the simple device right now that I told you, the glucometer, penetrance meter. So what we are doing? We are dropping the sample, we are getting the data. So everything, all the reaction are going on inside the device, right? So this is the main scenario of this point of care devices. So what's the beauty of this lab on a chip? So we can easily miniaturize, like no need the big instruments, very small, very small, like a coin, we can make it. And we need the very low volume of the sample. So generally for diagnosis, what doctors, they're taking almost 5 to 10 ml, sometimes the blood samples, and very much painful also. So we can avoid these things. We can make a non-invasive technique. We need, or if we need the blood samples, we can just prick your finger. Just a single drop of blood can detect. That's enough. So this kind of the sensors we can use for not only the medical diagnosis, also environmental monitoring, defense security, food safety. So we can detect the different kind of the bacteria, a different kind of food poisons also we can detect. And right now, in the worldwide, it's a very big market for development this kind of the device. Okay, let's give you one current scenario. The basic example is the diabetes screening, right? So this is low cost invasive technique right now available, right? We need to prick our finger and we should drop the blood and we can see the data. But think about if we think some baby, right now, in the developed country also, the very small, early age, they're also affected in the diabetes. Can you imagine how we can prick their finger in the daily basis many times? So it is very, it is not comfortable for them. So we should avoid this pricking the finger. But in some cases, actually non-invasive technique available, but it is very expensive. Don't imagine this is for the developing countries or for the rural area. We can't think about this. It's very expensive. So that's why some non-invasive technique at the same time is to be disposable. Just use it, throw it. That is very cheap. If we can develop, that will be useful for mankind. And lab on PCB. Now I will introduce one new topic, that is the PCB. PCB is the printed circuit board. I think electronic people, in every electronic instrument we have the printed circuit board inside, the electronic chip kind of things. This kind of things. This is called the PCB. So we can we can design whatever you want. You can design the PCB. You can fabricate the different kind of the electrodes on the surface. We can play around this. So these things you can see, this is the microfluidic channel we can design. We can design the different kind of this is called reference electrode, counter electrode, working electrode. We can immobilize our biosensor here. And because our PCB industry right now in the worldwide we have very well established technique. And because of the bulk productions, we can minimize the cost easily. So because of the well-established technique, minimize the cost, we can bring this technique to near the patient for the common people. That's why PCB is the very good solution for development of this kind of the sensor device and use them for common people. See, actually, we worked this on collaboratively with the University of Bath in UK. So actually, here we developed some sensor device for glucose diagnosis for baby. And we took the interstitial fluid using some microfluidic chip, and we detected different concentration of glucose. And this device, we just finished this device for glucose detections. We use the printed circuit board, and this paper just accepted in Biosensor Bioelectronics. And in this device, this is actually in the lab setup I'm showing you. Now, finally, it will come as a patch, very small chip that can be useful for glucose detections. So here actually we use some glucose oxidase enzyme using some chemistry. So you can see the reference electrode, counter working electrode. These 3 electrode is very much necessary for the sensor development. In the working electrode area, actually we are developing this kind of biomolecules. We are immobilizing the biomolecules. We are detecting the glucose. Okay, let's introduce some PCB. So this is the kind of some structure, the basic structure of the printed circuit board that we are using. Say here the microfluidics or different kind of we can use as a cathode or anode. We can use as a self-power biosensor device that can generate the power also. But we can easily fabricate and easily manufacture this kind of the chip in industry. But we are facing many problems for development. Our main goal to overcome all the challenges and finally bring the device for the mankind. That's what we're doing. See, first problem we faced, this kind of the sensor chip is not useful at the beginning, because when they in industry, when people the technicians or other people they are developing the sensors or developing the chip, but that contain lot of contaminant, lot of organic species. So in the XPS study, actually we saw the surface contain lot of organic species that is useless. But we remove all the contaminant, we clean them using our cleaning technique, and after cleaning, the surface was very, very clean and it was useful for the sensors. You can see that before cleaning there is no signal, and after cleaning we got the very good signal, and it is useful for the disease diagnosis. Yeah, this is another example. So this kind of the sensor chip actually we use for the S mutants. This is the Streptococcus mutants detection. This is responsible to the decay. So it's a very, very simple technique. So we are not using complicated chemistry. We are not using complicated mechanism, so that it will not be useful for the device. So what we will do, so we just, this is kind of the PCB surface. We are immobilizing the different biomolecules on the surface, like the antibody or aptamer or different kind of molecules we can immobilize. And if the sample content like bacteria, like S mutant, so it would easily immobilize on the surface. And now you use different kind of technique. Like here you use the impedance spectra, electrochemical impedance. If the sample increase in the concentration of the S mutants, then the signal also slowly it will be increased. So like this way, we can predict how much bacteria present in your sample. So here another example that is called the cell power. So think about this is very, very advanced. The miniaturized one kind of chip. We can easily develop something like the banded type. So all the things will be there. So sensor will react with your sweat sample, with the interstitial fluid, and it will give the signals. And also at the same time, that chip also will contain some cathode and anode. So say from as I told you, the glucose already contains in the interstitial fluid. So it will extract the glucose, and that glucose will react with glucose oxidase enzyme. And sample already contain like oxygens also, because our aerial oxygen can easily available in the sample, and that can react with cathode. So we can easily develop some cathode and anode, and we can develop the potential difference, and we can generate the power, and that power will help you to transmit the signal via Bluetooth to your mobile electronic device like smartphone. Yeah, now the another things, see, like sometimes we are forming the sensor device using different kind of the biomolecule. We should think about the stability of the sensor always, because if we can't store the sensor device in a long time in the room temperature, then sometimes it is very difficult to use in the rural settings. We can't store always our sensor in the refrigerated system. So that's why we are trying to avoid different kind of the engine. So we are trying to use different kind of nanomaterials, so that can react with different like biomarkers. It will give the signals. So this is one kind of the basic data we have, like different copper oxide nanomaterial we used here for glucose detections, and where we avoid the glucose oxidase uses. Yeah, now another things I will show you here, the malaria detections that I already mentioned. Now come to the commercialization part. See, this kind of the device actually easily we can miniaturize, because this is very small. We can easily integrate with the smartphone, and now this one ready to go for the commercializations. Actually, this is my collaborator in the Michigan State University, US. He already tried for field testings, and we have very good data also for this. And recently, we also developed one sensor device that recently published in the Nature Journal Scientific Report. So there also we just with a drop of blood, we detect the malaria within 5 minutes. So we use the layer by layer defined paper. In the paper contain actually many reagents. So you drop the samples, it will come to the reagent, and this antigen will bind to the surface to generate the signal. And this one as a chip, we can easily integrate to the mobile device, and we'll get the signal. So here actually we use some basic mechanism, like if your sensor surface contain the malaria, then it will show something like this. One protein layer will form on the surface. Then this kind of the reaction process will be very slow rate. Then we will get the lower signal. And if your sample not contain any kind of the biomarker or any disease marker, then there will be no protein layer on the surface. The reaction will be very fast. You will get the higher signals. Now the future. So this kind of the biosensor technique is very much useful, right? Also in the current scenario of the COVID, we can easily develop some sensor device or some printed device, and we can easily drop the samples. And if this contain the virus or bacteria, like COVID scenario, if this is the SARS-CoV-2, it will bind to the sensor surface, and by the use of electrochemical impedance spectra or different kinds of chronopolyometry or cyclic voltammetry, it will give the different signal. If there is a SARS-CoV-2 or COVID-19 present, a COVID virus present, then it will go the lower signal. If they're not present, it will be the higher signals. So we can miniaturize easily the sensor device, and basically we are trying to think about use this kind of technique for the rural area setting for the common people. So breakthrough discovery cannot change the world if they do not leave the lab. So we are not thinking about just do the research and publish the paper and finish it. So let's try to implement it to the sensor chip and try to connect to the company, connect to the industry, so that we can manufacture them and we can bring to the common people. And another things I just want to mention, the translational health research that right now we are doing. So translational research means that we're bench to bedside diagnosis. So bench means what we are doing in the laboratory and bring to the bedside applications. So you see right now in the current scenario, the COVID case, so we're developing some sensor device and we'll bring to the near the patients, and we'll try to find out what kind of problem we are facing. Then that kind of challenges we'll summarize, we'll bring to the lab again, we'll overcome this kind of the problem, and again we'll try to use them for the bedside diagnosis. So if everything's all the problem if we can solve easily, then finally we'll bring this device or this kind of thing in the market. So also we are using different kind of nanotechnology for cancer diagnosis, for disease diagnosis, for different kind of nano machine, which can bring the drug to the target area of the patients and destroy the the cancer area, and so that you can easily improve the disease stage. So that's the final slide for my presentation, the commercialization that I told you. This is my and our group that right now we're focusing, that is the commercializations. So that things that I already mentioned, that malaria device, and that kind of the device, a very, very simple device that just drop the blood within 5 minutes, we can detect the disease. That our main goal of the research. That the new technology we want to bring in the market so that people can get the benefit. So thank you very much for listening to my this nanobiotechnology enabled devices and modern technology and the basic fundamental chemistry that we are using for development of the sensor devices. And we want to, that our main things, main motive our IT corporate dedicated to the service of the nations, that we are trying to develop something for the mankind. And I want to thank my other collaborators like Michigan State University, USA, University of Bath, UK, and my other and Pusan University, South Korea, and also my collaborator IIT Guwahati. Also, I want to give my big thanks to IIT Kharagpur for all the facilities, and ISRT means our funding agencies, everything. So thank you very much, and thanks all for participating in this international webinar. So I welcome your questions. If you have any question, you can ask me also so that we can discuss.
That was great. It is indeed true that in order to provide better quality healthcare, high standard of healthcare management have to be achieved. And thus development of nanosensors for point of care diagnostics is an important area of research. Thank you very much, sir, for your inspiring words.
Thank
Okay,
you.
for the participants, I would like to mention that there will be question answers session where our speaker, Dr. Gorachand Dotto, will be answering your questions. So please write down your questions. I repeat, Sir Gorachand Dotto will be answering your questions. If you are having any kind of questions, you can write down and Sir Gorachand will be answering your questions. Okay, let me check whether there is any kind of question arising. Participants, if you are having any kind of questions, you can write down there wherever you are, like, mentioning your informations. Like, okay, here I'm getting one questions that is written: how would you justify sweat to be appropriate choice for blood glucose determination in non-invasive methods? It is a question from Rohit Mahato. He wants some more information regarding how would you justify sweat to be appropriate choice for blood glucose determination in non-invasive methods.
Yeah, yeah, very good question. So why the sweat? See, right now, the technique that available, that is for the glucose monitoring the blood samples. That is easily available in the market, the glucometer, right? But why we choose the sweat? Because the first of all thing, the basic important things like non-invasive. So non-invasively, we can easily correct the sweat. So actually, that we are doing currently the research, not only the sweat, also interstitial fluid, just under the epithelial membrane, we can get the interstitial fluid also. So for that, actually, we use this very that's called the micro needles. The very that is not painful. That's like a patch. We'll put on the skin, and it will absorb the interstitial fluid, and we can detect. So we have the data. I mean, how much glucose is present in the interstitial fluid or in the sweat samples, right? So now, that kind of the sweat actually will come to the through the microfluidics, and it will come the sensor device that already contain the glucose oxidase modified surface or copper oxide nanoparticle that currently we are using. So it will react with this, and it will give the signals like the blood. But I think the questions can, because it contains a lot of the interfering species also, right? So that's why our main challenge to how to eliminate the interfering species in the sweat or interstitial fluid. So for this, actually, we are making our sensor very much specific, and we are making the artificial like interstitial fluid samples like this, and we are dropping on the sensor surface, and we are trying to check if there is the interfering species effect is there. If their effect is there, we always trying to improve them. And basically, as the sensor is very specific that we already developed, and the range of the glucose, actually we already taken from some reference publications, the how much glucose is present in the in the sweat sample or interstitial fluid. Then we can predict this sample because of the diabetes. And actually in the interstitial fluid case, this concentrations is very low. It is around like micromolar range. So that's why your sensor should be very sensitive. So we tried develop the sensor is almost 1 microgram, 1 micromolar or less than this sensitivity, and we succeed to develop this one. So we can detect the very low level glucose, and we can implement them for the sweat sensor or for the interstitial fluid sensor for glucose monitoring. Thank you.
Mr. Mahato got your answer. So I would like to ask you next question, which is from Mr. Mukul Mahato. What are the roles of organometallic chemistry in medicinal chemistry?
Yeah,
So this
see,
is
see, as my basic is the chemistry also, yeah, I can tell you the answers here. What are the roles of the organometallic chemistry? See, organometallics means, see, we are using different kind of the linker, like some a big organic moiety, and there is some metallic part also, like ferrocins or something like this. We can use them for the biosensors. We can use them as a mediator. So why? So mediator actually will react with the nanomaterials or with some basic reagents, and it will help to generate higher signal to background ratio. As I repeatedly, I mentioned many times, for early stage disease diagnosis, we should develop a device that should be useful for, it should generate the higher signal to background ratio, like so that we can detect the disease early stage. An organometallic substance or organometallic compound actually can react as a mediator. It will help the higher signal to background ratio. So basically, just think about this one for early stage device development. It would basically developing for signal generations. Thank you. Next question, please.
asking you next question, and that is from Samrat Chaudhary. He has asked you that in case of glucometer, we could notice a small fluctuation in test result. So, sir,
Hmm.
are there any measures that should be taken before using glucometer to get a perfect result?
Okay, so it means, so yeah, that fluctuation is quite common, right? So that's why actually right now we are focusing, say some optimization technique. If there is some fluctuation, so how much impedance is changed. So accordingly, we are self optimization some technique actually we are incorporating with our that sensor pass that we are going to develop. See, so somehow maybe there's sensitivity maybe when if you store for the 1 month. After 1 month and when you develop, maybe that activity may not be the same. It's true, but there is some impedance change will be there. So we are think about that change of the impedance, and we are optimizing that impedance, and we're trying to correlate that value how much change there. And based on this, actually we actually work with our collaborator in the Lancaster University. So they actually help us to develop this kind of the device. So how we can optimize this change with time to time, and it is possible. And I mean, the question is very good, but it is possible to monitor this change.
From Dr. Gorachat, sir. Okay. Next, any new question I'm not getting, but I got a question that is from Satnam Jaswal, and that is how to use this information in current scenario. I don't think that it's a full question.
What question?
Uh,
Can you repeat?
just a sec, sir. Question is not full. How to use this information in current scenario?
Okay, I mean, basically, he's asking the current COVID-19 situation, how we can use our technique
Yes,
for
the
SARS-CoV-2
nanotechnology.
detection. Yeah, that's
Yes.
I always say. If you see my slides, so as I mentioned, so there is so many biosensor devices we developed. So on the basis of this, so everything, I mean, this kind of topic, this kind of the technique, actually, you can easily implement to a miniaturized device. So actually, we can use some very specific bioreagents, so that can specifically target our SARS-CoV-2, and we can see. So if the target concentration of if the SARS-CoV-2 present, so it will bind to the sensor surface, and it will give some form of the signal, like by the help of chronoamphometry, chronocoulometry, or impedance change. You can see that value. And at the same time, I mean, which stage is the very early stage or the advanced stage, that also you can predict. I mean, some quantitative information also you can predict. So with the base of this one, yeah. So in the current scenario, in the basis of this, so we can develop this kind of device, and I'm also trying. So let's see. Thank you. So please, next question.
Question I'm getting here, and that is from Mongoldeep Bormon. What
Hmm.
measures taken into the mentioned device to reduce quenching effect of other organic materials? I guess this question is from your presentation that you have shown. I guess.
What measures taken into the mentioned device to reduce quenching effect of the other organic material?
Yes.
So reduce the if you think about the quenching effect, see this is kind of see that I showed you. Generally we are developing right now some electrochemical, but if you think about some their interference effect, so in this case actually we are developing some specific material like nanomaterial these things, and it is very much challenging and fast stage we have to overcome. So that is the main stage. So we are trying to make some hybrid compound or some very specific, we are looking for some specific material that is only useful for them, and we are trying to develop so that no other compound that present in the biological samples or from any other, or if you think about some environmental monitoring like some waste sample, so it contain many organic inorganic species, so that can hamper your sensors. So the main things, that's why you always think about the specificity first of all. So that actually we always focusing. So if this stage done means almost more than 50% work is finished. So you can go for the next stage. So yeah, so for this you have to always think about the specificity. So check it. If it is not, if your sensor is not specific, then redesign it, and then change the materials, and then again drop this kind of the quenching material or interfering species material and check it. So this is the actually process.
I guess I would be asking you one last question that is from Pritam Mukherjee. And his question is, can you give some insight on implications in regenerative medicine?
Okay, can you give some insight on implementing implications in regenerative medicines? Okay, so regenerative medicines, see, so it means, see, as I told you, lab on a chip, but we think about organ on a chip, brain on a chip, tumor on a chip. Means all the disease things you can bring on the chip. So if you have, I mean, we can get information. So just on the chip, like we can develop a device that can mimic your liver, then can mimic your brain, kidney. So these things we can develop. So that I told you in the lab on a chip technique. So if you can develop this one, so you can get lots of information on the small chip. So then we can predict what you should go for. What will be your next stage? How you can go for the animal trial, something like this. Then if you get some data from a chip, a small chip, then you can go for the animal trial. So like this, it will help you for development of the regenerative medicines. So this is very, very advanced topic. That's why I'm always telling you the lab on a chip. Everything bring on a small device. Okay, thank you. So any other questions there?
No, sir, I'm not getting any questions right now. Okay, thank you very much, sir, for this inspiring, for your inspiring words, and it has been a lovely question answer session. And I think that our participants also got lovely answers, and they are satisfied with their answers, I guess. And thank you very much, sir, for your so precious time.
Thank you. Thank you very much for your nice invitations, and also thankful to you also. Thank you.
Okay, sir. Thank you. Welcome, sir.
Thank you. Bye.
Okay, now it's time for our next topic of today's event, which is focused on the effectiveness of protected areas in biodiversity conservation in Tunisia. Well, we all are aware about biodiversity, right? Biodiversity boosts ecosystem productivity where each species no matter how small, all have an important role to play. Conservation of biodiversity is very essential for maintaining the Earth's environment and sustaining life on the planet. We can contribute too in this biodiversity conservation by increasing our knowledge of environmental issues, by increasing our awareness of the impacts of biodiversity loss, and by increasing support for government policies and actions that preserve our valuable ecosystems. To gain knowledge on this particular area, I feel very excited to announce the name of that special person whose vision is to promote the natural and ecological potential for our country. Dr. Rania Meshirgui, ma'am, I would like to respectfully request you to kindly join the session. Okay, I guess that we are facing some kind of network issues. So I would like to tell you something that if you people would like to share today's informative session, you can also share in your social networking site. You can use the social sharing option, which is popping up of your right side corner. You can click on that button and you can share this in your social network platform directly there actually. So I guess we are facing some kind of issues, issues basically, and we got a call from Dr. Rania Meshigui, who is going to give you the next very informative session regarding the next topic which we are going to air, that is the effectiveness of protected areas in biodiversity conservation in Tunisia. So I would request you participant to please tighten your seats because lots of information is going to come. Okay, so in that case, if you are facing some kind of timing issues, so I would like to tell you something regarding our college, that our college is a premier technical educational institute of West Bengal, and it is situated in Durgapur. It was established in the year of 2012, and it was been established by Sri Jayanto Kumar Chakraborty, the founder president of Rajendranath Education and Welfare Trust. We are providing diploma engineering courses in the field of civil, mechanical, electrical, and also in computer science and technology. We are basically endeavoring with lots of innovative ideas to pursue our students with a very good knowledge, and also we are providing the students in higher education on a consistent basis. Our college, Rajendranath College of Polytechnic, basically approved by AICTE under the Ministry of MHRD. Uh, Presently, it constitutes with four branches, that is mechanical, electrical, civil, and computer science and technology, and it offers a 3 years diploma program in engineering leading to the award of diploma in engineering. This institute is situated in Durgapur. I think all of you know about Durgapur, and those participants are listening or joining us from outside West Bengal. I would like to tell you something regarding Durgapur, that it's a steel city and which is a very well known as an educational hub. Okay, and the institute is situated in the midst of West Bengal, that is in Durgapur, which is the first emerging city of West Bengal. India, and it has grown up to become one of the mega city of Eastern India. It is popularly known as the Steel City of Eastern India, and wearing its image in the field of education to become one of the multi-purpose cities in India. Rajendranath College of Polytechnic addresses the need for trained and specialized technical professionals for industry worldwide. It aims to develop opportunities for students and to develop the intellectual knowledge based with leadership skills to compete in the global arena. This purpose is being addressed through a number of technical education programs. Rajendranath College of Polytechnic is all about trustworthiness. It has its own ability of purpose to envisage, build, and convey an institute of high academic standard. Rajendranath College of Polytechnic aims to create a better India by efficiently preparing the youth to cater the technological advancement of the century. The innovative teaching techniques have set the students apart from the rest. Thus, we make RCP as one of the best diploma college in West Bengal. Rajendranath College of Polytechnic has a vision of conveying truly world. We offer true class and quality education to our students with access to the curriculum delivered by the highly qualified and committed faculty as well as the right pedagogy and environment. Rajendranath College of Polytechnic students gain an education with a future perspective. I would like to request the participant, whoever is watching right now this live international webinar on two different topics, which are very different and which is those topics are going to cope with the, like, current scenarios. The first topic was nanobiotechnology enabled biomedical sensor devices for point of care disease diagnosis, which was being delivered by Dr. Gorachand Dotto, the speaker, today's first speaker actually from School of Medical Sciences and Technology, IIT Kharagpur. And our participants got immensely good response and they are also satisfied by the answers which has been provided by Dr. Gorachand Dotto. Rajendranath College of Polytechnic as a premier technical educational institute, I have already mentioned that we are situated in Durgapur and we are offering 4 different courses in diploma engineering field. And we are offering civil engineering, mechanical engineering, electrical engineering, and also computer science and technology. We are offering right now, we are taking admission and you can get the banner that is providing us in the below of the session and you will get the number over there and you can contact there and you can take direct admission from there. Okay, so Rajendranath College of Polytechnic is under Rajendranath Education and Welfare Trust, and we are also having another sector which is providing us courses on B.Ed, M.Ed, and D.El.Ed. And the institute name is Rajendra Academy of Teachers Education, which is known as RATE, RATE. And this particular institute, which is also our sister concern, is providing us with different sectors like different subjects like, it on M.Ed, B.Ed, and D.El.Ed. And Rajendranath Engineering of Private ITI is going to give courses on electrician and also in fitter. So basically, Our college, Rajendranath College of Polytechnic, okay, so participants, please hold, sit in your seats and please give us some time. Actually, we are facing some network issues. That is the reason that Dr. Rania Meshegui is not been able to connect right now. So please give us a moment. Okay, so let talk about something special regarding our college. Our college is not only one diploma engineering college. We are also having our sister concern, which is applying or which is providing us with MAd, BAd, DLAd, and also providing us some kind of ITI, private ITI coaching also, which is depending on electrician, fitter, this type of courses we are offering. Okay, so in case of rate, like Rajendranath Academy for Teachers Education, I would like to share some kind of information in this particular time that Rajendra Academy for Teachers Education is NAAC accredited with the purpose of advancement of knowledge, attitude, and skill for developing prospective teachers through teacher education programs. The college runs teacher training courses on BEd, MEd, and DLEd for catering the expanding needs of qualified and competent teachers in India. For qualitative enhancement of teacher education, the college has been running the courses of study from 2009, which is duly recognized by NCTE and affiliated to WBUTTEPA, the University of Bardhaman, and WBBPE. This college is situated in the sprawling campus of 19 acres amidst greenery and pollution-free environment. The three wings of the college functions in a collective way, keeping parity with the composite structure. Rajendra Academy had been focusing on the teaching competencies among the aspirants with qualitative dimensions for the elementary, secondary, and higher education level. The college is located at a distance of 5 kilometers from Durgapur railway station and 3 kilometers from Uchipara. Okay, I would like to tell you, whoever participants are watching this program from not from Durgapur itself, but rather from Jammu Kashmir, I can see that lots of participants are from Jammu Kashmir, are from Kerala, Hyderabad. Apart from West Bengal, those the participants are watching this live international webinar. I would like to tell you that this particular college is situated in Durgapur, which is known as Steel City. Okay, and it is also known as an educational hub. So I would like to request our participant to please give us some minutes to co-op with the situation, as I know that you are also impatient right now. You also want to listen and you also want to gather lots of information regarding the biodiversity conservation, which is the effectiveness of protected area in biodiversity conservation in Tunisia. And in this second session, we are having a very good informative session, which is going to give a speech by Dr. Rania Meshegui, and she is facing some problem right now due to some network issues. She is not been able to present right now. So I would like to please request our participants to give us some time and please be patient because lots of informations, lots of ideas are going to come in this next session. Okay, so I guess a lots of time I'm repeating this word Durgapur, Durgapur, and it is in West Bengal. So lots of participants, whoever attending this webinar from around the world, actually, I guess they have already served this word in internet or in Google that where is Durgapur situated at, right? So I would like to tell you something more about Durgapur. You would love to know that Durgapur is the fastest growing emerging city of West Bengal, in India rather, which is growing to become one of the mega city of Eastern India. Durgapur, popularly known as the Steel City of Eastern India, and it is varying its image and emerging also in the field of medical and also in education to become one of the multi-purpose city of India. Durgapur has a huge base of industries with two kill city plants in Durgapur. City center is the nucleus of Durgapur city's administration. I guess I know that whoever is from Durgapur and outside Durgapur, those have already heard about city center. It is the heart of Durgapur city. But those who have not heard about this particular place, you can know from this session. Actually, I am like telling you. I am going to tell you some more information about Durgapur. Actually, okay, so Durgapur is already growing for its medical facilities and educational institute. It has many famous schools, colleges, okay, and other institution. Better you can know that Durgapur city is better known as an educational hub. In the field of entertainment also, it has many entertainment center, richly known as clubs, wide range of shopping malls, and magnificent parks and picnic spots. Durgapur took pride in its cultural activities through being a relatively coming up new city. It provides a wide range of opportunities to its residents and visitors from outside location. To accomplish the need of any information about Durgapur, the website has been launched and you can also visit the website. You can also surf in Google. You can, go through the pages and you can know about Durgapur. And if you type our college name, that is Rajendranath College of Polytechnic, you will be getting, and it is going to show you on the top of the page, and which is known as the number one diploma polytechnic college in West Bengal. Our college is offering four different diploma classes, that is depending on civil, mechanical, electrical, and also in computer science and technology. It is established in 2012 and it was established by Sri Jayanto Kumar Chakraborty, the founder president of Rajendranath Education and Welfare Trust. Not only Rajendranath College of Polytechnic, we are also having our sister concern, that is Rajendra Academy of Teachers Education and also Rajendranath Engineering Private ITI. So basically, direct admission is going on and you can get the phone number or contact number that is provided below on the page on the session basically, and you can get the link and you can contact there to get direct admission. And for the participants, those are listening patiently. Okay, so I would like to request you participants to share today's webinar with your social networking platform. It may be Twitter, it may be Facebook, it may be Instagram, it may be LinkedIn, wherever it may be. And you can use the social sharing icon, which is popping on the right corner of your session of your player, and you can post these particular international webinar on your social networking sites. So the participants, whoever is patiently watching this international webinar, I am very much thankful, and we are very much thankful for you people who are patiently watching this webinar and who have already waiting for the next session. I would like to request you people to please sit in your bales, because I think that we have already got some signal from Dr. Rania Meshegui, and it is a very good sign. Okay, so please give us some few seconds. Actually, maybe some problem I'm facing right now from Dr.
Yes.
Rania Meshegui. Yeah, ma'am, are you listening?
Hello. Hello.
Yeah, ma'am.
Hello, everyone.
Yeah, ma'am. Please be
Hello, everyone.
online.
I'm so sorry because I have a problem. I found my presentation with another presentation last day with another presentation with I can't found my presentation today, but
No worry, ma'am. It's not a big
oh,
issue, ma'am. We all face the same problem wherever.
just
No,
uh,
no, don't worry, ma'am.
no.
You don't need to be so sorry.
So
Okay.
sorry
No, 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 ma'am. Don't be so, ma'am.
because I
No, I
don't found.
understand your situation, ma'am. Don't be so sorry, ma'am.
Please.
Okay.
No.
Okay,
Uh,
participants. We
uh,
have right now Dr.
I can
Rania
screen. I
online.
can screen or what can
Yeah, ma'am. We are taking you online. Okay. Whatever information you
online,
have.
but I can speak just speak. Uh,
Yes, ma'am.
or, just 2 minutes.
Okay, no issues. You can take your time, ma'am. Ma'am is requiring for another 2 minutes because maybe she is going through her presentation. Okay. So,
Okay.
anyways, no issues. We are we got Dr. Rania Meshegui right now, who is online right now. So, it is time for our next topic of today's webinar, the next session, which is the effectiveness of protected areas in biodiversity conservation in Tunisia. Well, we all are aware about biodiversity, right? Biodiversity boosts ecosystem productivity, where each species, no matter how small, all have an important role to play. Conservation of biodiversity is very essential for maintaining the Earth's environment and to sustain life on the planet. We can contribute to in the biodiversity conservation by increasing our knowledge of environmental issues, by increasing our awareness on the impact of biodiversity loss, and by increasing support for government policies and actions that preserve our valuable ecosystems. To gain knowledge on this particular area, I feel very excited to announce the name that special person whose mission is to promote the natural and ecological potential of a country, Dr. Rania Meshegui. Ma'am, I would
Yes.
like to respectfully request you to kindly share your views on the effectiveness of protected areas in biodiversity conservation in Tunisia. Ma'am, the screen is all yours now. Please continue, ma'am.
Thank you so much. Sorry to disturb with my presentation because I have a problem to found my to open my presentation. I have a problem. Hello everyone. I would like to warmly thank to Honorable College Rajendranath College of Polytechnic for this invitation, and a great pleasure to for Professor Senga for invite me in the international webinar. Many thanks our speaker and our audience. Today I talk about efficiency, the effectiveness of protected areas in biodiversity in Tunisia. At the beginning, I talk about climate in Tunisia. The climate in Tunisia is characterized with Mediterranean climate, and Mediterranean climate, hot temperature and precipitation, increased precipitation. In Tunisia, we have 17 national park for conservation and protected, and natural natural. You see me? Yeah. I don't see me. And natural and 17 natural park and natural park and 7 natural reserves for fauna and flora. In Tunisia, the richest specific species in it's controlled by Minister of Environment and General Forest General in Tunisia, and the IUCN International Center for Conservation Nature implique in this park to protect the fauna and the flora, and the governance and use the management this park, good management to implique green list. It's process to evaluate the management of national park, the protected areas for conservation and protected. Just to focus in richness and valorization the vegetable species and fauna. The richness in Tunisia, because we have a different different altitude, different topography. The mapping in Tunisia, it's variable in parameter and ecological parameters in the area, in this area to north in the sea, because in the north we have a lot of species, because the climate gradient is without precipitation, increased precipitation. For another hand, in the south of Tunisia, the precipitation is reduced. The vegetation, the vegetable varied. It's varied to the north and to the north in the south. The most interesting protected areas, because in Tunisia we have a livestock, a lot of livestock in the north to explore the vegetable and the vegetable, the riches is very important to aliments and socio-economic for population, and the role of the protected areas, because the protected areas not exploit not is not management, no valorization in the protected areas. The vegetable, vegetable, it's very important number and richness and dominance and abundance species. But in different sites in Tunisia, we have extended species to appertinent and red list. Red list, it's the focus in the species to extent degradation species in Tunisia, and the role of the red list, we have different categories: the extant species and threatened species, and the list concern the species. The extant species is reasonable double that the last individual has died. The extended in the weeds now only to survey in captivity, cultivated or outside in natural range. We have also near threatened, close the quantified and likely to quantify for threatened category in the near future, and another and a category to reduce the species. No, three category in the red list, but in 2017 we create UCN create the green list to evaluate process indicators and category and criteria to evaluate the governance and management the protected areas, just to favorite the species and fauna and flora. In Tunisia, we have a major problem because because climatic change in Tunisia, because we have farm level to the farmer level do drought and salt stresses in Tunisia to the interest the protected areas. We have also different species in national park specific. For example, in national park for Bohedma, we have a specific species. The name is specific. The species is Acacia radiana. The most important species in the site to preserve the species in this park. In Bukarni National Park, in the north of Tunisia, we have Tetraclinis articulata. It's the native species in the park, and adaptation. The species is adaptation in the park and the site with ecological parameters in this site specific. What else? What about climate change to behavior the natural park and national park and protected areas? on general in the site of Tunisia, because actually we have a fire, and we have we have a problem with the drought, and drought in Tunisia, to the character to maintain the species, native species, and valorization the species, and introduce. It's very, very important. Thank you so much. I'm sorry, very, very sorry, because I have so problem. Thank you so much.
Well, thank you very much, ma'am, for your great words. Yes, you are absolutely right. Only by doing so, we can ensure a future for nature and
Yeah.
for all the benefits it's bring to people everywhere. And then we really will have a new deal for nature. So, for participants, I
Yes.
would like to ask you, if you are having any kind of question, you can write down, and our speaker, Dr. Rania Meshegui, will be answering your questions. Participants, I would like to request you,
Thank
if you
you.
are having any questions, please write down. Our speaker, Dr. Rania Meshegui, is going to answer you. Okay, I got one question, and that is from Ralph Neri Tabat. The question goes like this:
Yes.
Are
Yes.
there some, yeah, are there some endangered species in the protected areas?
Yes, yes, because actually we have a problem to climate change in Tunisia, because because we have a precipitation, low precipitation, but temperature, extreme temperature, very, very increase. I we In Tunisia, the species, it's unfortunately it's very important, but we must conservation and protect the species, to adaptation, the species, and we have use the native species to adaptation, and preserve the species.
Thank you so much, ma'am. I think that Ralph Neri Tabat, you got your answer from Dr. Rania Meshirgui. Okay, so I'm not getting any more questions. Participants, if you are having any kind of questions in your mind regarding this particular session, the effectiveness of protected areas in biodiversity conservation in Tunisia, if you have any kind of question that is arising in your mind, you can write down, and our speaker, Dr. Rania Meshegwe, is going to answer you. Okay, so I got another question, and that is from Inu Inu. I guess this particular participant is from Jammu and Kashmir. Okay, the question goes like this: How should we protect our animal species?
Yes, yes. Can you repeat your question, please? Can you repeat
How
your
should we
question, please? Okay, okay, yes, yes, I see. How should be protected anonymity? Yes, it's very nice question. The protectors in animal in the fauna on general uh, in the protected areas. I multiplied a lot of fauna and protected the species, the fauna.
Okay, thank you. I got Inu got her answer. Yeah, she gave some kind of three smileys also. The like she is satisfied with her answer. Okay, so no more questions. So thank you, ma'am, for your participation, and thank you, ma'am, for your precious time that you have given us.
Thank you.
And we would
I'm
like
so
to
sorry.
thank you. And it is our heartiest thank that we want to show you that in respect with all kind of problem that you faced
So
during this
sorry.
session regarding network issues or regarding your presentation, whatever, but you gave your time and that is very much appreciable, ma'am.
Thank you. Thank you so much. I'm so sorry for the perturbation because
No,
thank you
ma'am,
so
it's
much.
okay. Okay, so we are on the verge of this total session that we have covered today, the two different scenarios that right now we are facing in our world. So I would like to call upon respectfully the principal of RATE, Professor Dr. B.C. Swine, to please convey your vote of thanks.
Thank you.
Good afternoon. We are on the verge of these 3-hour international sessions that focused on two-way different topics: nanobiotechnology, enabled biomedical sensor device for point of care disease diagnosis, and the effectiveness of protected area in biodiversity conservation in Tunisia. I would like to extend a very hearty vote of thanks to the speakers for giving or gracing you important work and sharing with us your findings and opinions today. I am like to express my sincere thanks to respect speakers, Dr. Gorachand Datta, to provide us with the excellent idea on point of care disease diagnosis with its future aspects and innovative strategies. I am also wish to express my gratitude to Dr. Rania Mekagui that she has remind us that we cannot negotiate with nature, but we can negotiate on behalf of nature. I would like to take this opportunity to place on record our hearty thanks to our respected chairman, sir, of our college, Sri Jayant Kumar Chakraborty, director technical, Sri Kajal Das, CEO, sir, Sri Madan Sarkar, our principal, sir, Professor Tanmaya Singha,
other dignitaries for the perfect support and guidance that has extended to all of us at this event. Finally, a big thanks you to our colleagues, participants, and students for their gracious presence. Thank you all for making this event successful with our contribution. Namaskar.